Hey guys, welcome back to my channel. This is Mohammad Arshid. Currently, I'm pursuing my Bachelor of Engineering in Sri Venkateshwara College of Engineering. So, I'm from third sem. My department is CSE. Today's subject is mathematics, and the topic is about ANOVA technique. So, let us detail know about ANOVA technique. First of all, it is the introduction of ANOVA. ANOVA basically stands for analysis of variance. It is a statistical method used to compare means among three or more groups. The goal of ANOVA is to determine if at least one group mean is significantly different from the others. As you can see in the uh, image, this is how it was, the formula and all. So, and the next is types of ANOVA. There are several types of ANOVA, including one-way, two-way, and repeated measures. So, one-way ANOVA tests differences among groups based on one independent variable. Two-way ANOVA assesses the influence of two independent variables on a dependent variable. You can see in the table as well. So one-way ANOVA used with categorical predictor variable and one continuous response variable. And the repeated measures one-way ANOVA used with categorical predictor variable and continuous response variable. So it's different. It's the same, it's not different, but in when it comes to subjects, each subject only appears in one group. In the repeated measures are one-way ANOVA technique, each subject appears in each group. So next is what is one-way ANOVA? One-way ANOVA is used when there is one categorical independent, as we know this about we saw in the previous slide. This technique helps identify if at least one group mean differs from the others. It does not indicate which specific groups are different. Post hoc tests are required for that. So when it comes to two-way ANOVA examines the impact of two independent variables on a continuous dependent variable. This method can also evaluate the interaction between the two independent variables. It is beneficial for understanding how multiple factors influence outcomes simultaneously. So next is assumptions of ANOVA. ANOVA relies on several key assumptions for valid results. These include normality, homogeneity of variance, and independence of observations. Violating these assumptions can lead to inaccurate conclusions. So, what are the assumptions? We can know detailedly. It has a independence, normally distributed, homogeneity of variances, and the purpose of it is examine these assumptions, provide various tests for these assumptions. So yeah. So next is hypothesis in ANOVA. ANOVA operates under a null hypothesis. It's not an alternative hypothesis, H1. The null hypothesis states that all group means are equal, while the alternative suggests at least one is different. The goal of the ANOVA test is to assess the validity of the null hypothesis. You can see it in detail in the table. Next one is F ratio. This is the important factor in the ANOVA method. The F ratio is a key statistic in ANOVA representing the ratio of variance between groups to variance within groups. A higher F ratio indicates a greater likelihood that at least one group mean is different. The F ratio is compared against a critical value from the F distribution table to determine significance. So next is the applications of ANOVA, guys. ANOVA is widely used in various fields such as psychology, agriculture, and medicine. Researchers use it to analyze experimental data and understand group differences. So it is particularly useful in controlled experiments where multiple treatments are compared. So next is the limitations of ANOVA. ANOVA has limitations such as its sensitivity to outliers, which can skew results. It also requires assumptions about normality and homogeneity, which may not hold. sorry, which may not always hold true. Additionally, ANOVA does not provide information about the direction of differences between groups. Interpreting ANOVA results involves in analyzing the F statistic and p values. P value is basically less than 0.05 typically indicates significant difference among group means. So also it is also researched that it should be considered effect sizes to understand the practical significance of results. So we'll go through an example of ANOVA. A practical example of ANOVA can involve testing different fertilizers on plant growth. So as we have discussed in the previous slide that it is also used in the factor of in the field of agriculture also. We are taking that as the example. Researchers would measure plant heights across multiple groups treated with different fertilizers. So ANOVA would determine if there are significant differences in growth attributed to the type of fertilizers. So last part we'll just glance what we have discussed and all. So the conclusion is basically ANOVA is a powerful tool for analyzing differences among group means in various fields. Understanding its assumptions and proper application is crucial for valid results. By mastering ANOVA, researchers can make informed decisions based on statistical evidence. So it can be expanded on any specific slide or request additional. So thanks for watching, guys. Hope you got the concept very well.